Got a K1, K1 Max, K1C, you rooted it, you ran a bed mesh, first thing you see is something that looks like this. Stick around. Hey everyone, welcome back. I'm Scott, Edge of 3D. This is a K1 Max, and this is the one that in the previous video we rooted it, and then we updated it. And as you've seen in the bed mesh, it looked something like this. So there's Creality's way of doing it, which requires that you run the bed all the way to the bottom, flip the machine over, take screws out, put screws in, undo the belt, screw these things down. No. There's another way to do it, which I've done on my K1, which involves just undoing the palm nuts. The problem is these are force start lead screws in these machines, so every revolution is 8 millimeters of bed travel. And doing the palm nuts, you have 4 positions, so each quarter of a turn is 2 millimeters. That's too much. Creality's method, jumping teeth on the gears, well again, 8 millimeters per revolution, 20 teeth on the gears, so one jump is 4/10 of a millimeter. What if you're out 7/10? Do you jump it to 6? Do you jump it to 8? So I'm going to show you another way. Anyway, we're going to put spacers in here. We're going to get this bed as level as we can. So let's get to it. We're going to hop over on the computer and I'll show you how I handled it. Okay, so we're going to run the bed mesh. We're going to get this bed as level as we can, at least on 3 points. These beds are not machined aluminum. They're not going to be perfectly flat no matter what you do, and adjusting 3 points or trying to adjust where the load cells are at, anything like that, you're not going to flatten the aluminum out. But all we can do is get the 3 planes as close as possible. So before you even run your bed mesh and start working on this, I strongly suggest you take the cover off your extruder. On the K1, you don't have to worry about the LiDAR that you see here. On the K1 Max, in order to get the cover off the tool head so that you can access the 2 screws at the bottom, you're going to have to remove the LiDAR. There's 2 screws on the top here. I believe those were 2 millimeter. The front one can be a little bit difficult to get at because it's about directly underneath the upper X-axis bar. But take those 2 screws out and then just gently pull on the cable and unplug the LiDAR out of the side of the cooling housing. Remove these 2 screws here on each side. Take that cooling housing off, unplug the fan. Now, I caution you, make sure your machine is shut off before you do any of this. If you touch the wrong thing in there with something conductive, you'll end up needing a tool head board and most likely a motherboard. Ask me how I know. So once you get the cover off, you got to work the silicone sock off. I use a Allen key and I kind of work it into it and work around there and get it loose and kind of pull it down off there. It can be a bit of a pain to get off there. Just be very, very careful with where the wires are attached to the heating element. Those can be broke off very easily, and then you need a whole new hot end. Check to make sure the 2 screws coming in from the bottom that you see right here are tight, and then check the set screw on the back of the heat sink and make sure it's tight as well. What I did on mine is I reached around the back, and that's a 2 millimeter hex key to loosen that one up. I loosened the set screw up. Then I took the 1.5 millimeter hex key and I tightened both of these that you see right here. Then I went back around to the back and I tightened that back up. And then I reassembled everything. That way there's no chance of a loose hot end skewing your bed mesh. They would want to just eliminate any possibilities. So once you've got that done and you've reassembled the tool head, reassemble everything in the reverse order, let's jump over here. The way I do my bed mesh is I heat my heated bed up to 60. I've done it both ways, and there is a little bit of difference, and the longer it sits at temperature, the longer or the more stabilized it'll become. But as you can see here, I've got my heated bed at 60, extruder's setting at 180, and the reason I run the extruder up to 180 is unless you have a brand new tip in there, if there's any little bits of filament on the tip, there's a possibility that partway through the bed mesh that could come off. K1 Max comes on a 6x6 bed mesh, which would be down here. This would be set to 6x6. I change it back to 5x5, and the reason I do that, on the bed mesh here, this is the back side, I want the probe point right here at the screw. So 6x6, you'll have a probe point here and a probe point here, but you won't have one right over the top of the screw. So for the purpose of getting this bed leveled on the three corners, which is here, here, and here, I set that to 5x5. That way I have a center point to work off of. What I use are these spacers right here by Need It Make It. He has a video that basically goes over this exact same thing. I print all 9 of them. Then once you get the spacers printed, they're going to go into the corners. Now when you first open up your height map, it's probably going to look like this right here. This is the right front corner of the machine, this is the left front corner of the machine, and this is the rear. The way you know that is right down here. Your 0, 0 is your left front corner. So 0, 0 right here, and that's obviously, that's high on this machine. So we need to figure out what spacers we're going to put in there. Well, the easy way to do that, the probe point here is at 1.114. The probe point here is at 0.211. So it's about a 0.9 difference across here, but your screws actually set out quite a ways off these corners. So it's going to be an even bigger difference from here to here. Now the thickest spacer that he supplies is a 1mm spacer. Then back here, this is your high point, 1.114. This is your center point right here, 0.311. So we're looking at about a 0.8, and the screw on this one, or where this bed attaches to the lead screw, is just off the back here. So you can pretty well use the difference here. We're going to go ahead and put a 0.8 here. I think we need a 1.2 for here, and he doesn't have a 1.2. So let me bring up a Orca slicer here, and I will show you what I'm going to do to get a 1.2. This is the 1mm one right here. You can tell by zooming in on it's 1.0. So I'm just going to delete all the rest of these out of here. And we're going to move this over here. We're going to go to scaling. We're going to uncheck uniform scale. And we're going to go ahead and make this a 1.2. And then we'll slice it, and we'll upload and print it, and as soon as this is done printing, we'll come back and we'll get these put into the machine and recheck our bed level. Okay, so we have our new printed spacer right here, and I printed it on the other machine. I'm running a 0.6 nozzle, I'm running carbon fiber ABS, so something that thin like that, it's not going to print real well. But what we're going to do is just remove these 2 screws right here. Real simple. You don't have to take the whole bed off. You don't have to disconnect any wiring. Just pull these 2 screws out right here. And if you have a magnetic screwdriver or bit driver like this, they'll stay with it. I have to excuse my hands in there. It's not the easiest place to film that without taking the side covers off, and I'm not taking the side covers off, so because most of you won't do it to do this either. Got the 2 screws out, take the little spacer, lift this up, and just slip the spacer in there. Might have to wiggle it around a little bit till it drops down in the alignment hole. If you don't have a set of these little dental picks from Harbor Freight, they're a great investment. There we go. Heard it drop in there. We'll go ahead and reinsert these 2 screws, and we'll move to the back. It's a little bit more difficult. You got to take the screws out of the top and then slip the spacer in from the bottom. Now these are direct threaded into plastic, so don't just go reefing on them and strip the plastic out, because once you do that, then you're needing a lot more parts. Just screw them down snug. Again, I apologize for my hand in the way. And there we go, that spacer's inserted, so now we'll jump over here and we'll do the back. And here we are at the back screws. Same thing. Just take the 2 screws out. Now this is going to be one of these do as I say, not as I do things. I really recommend you take your bed plate off, because working around here you're going to be bumping into the rods and stuff like that and getting oil on your hands, and then inevitably you're going to touch the build plate and create a spot on the build plate that doesn't stick. So there's the 2 screws. We're going to take this spacer here, we're going to go down underneath, lift up on the bed a little bit, and we're going to slip that in there. Okay, here we are on the bottom side of the bed, and we're going to go ahead and put that spacer in there. So basically you just lift up on the bed, slip the spacer in there, kind of work it around until it drops in the alignment. And again, you might need to take a little pick or something and kind of move it around a little bit and play with it until it drops in. There we go, it dropped in. Now we'll go back to the top side and we will put the screws back in it. Okay, here we are back at the top side after we got that spacer in there, and we just want to put these 2 screws in. Sorry about that, didn't mean to bump the camera. Again, same thing here. You're screwing direct threads into plastic. Don't reef on them, over tighten them, and strip the plastic out, otherwise you're replacing that whole part. And right now it's Chinese New Year. You're not going to get very many parts. Okay, that's it. Our spacers are installed. Let's warm the bed back up and we will do a bed mesh on it and see how we did. So I'm going to go ahead and start heating the bed up here to 60. Heat the hot end to 180. We'll be right back and we'll run the bed mesh. Okay, there's our new bed mesh, and we're still out 0.86, and for some reason this left rear corner here has dropped way down, and I don't know why, because our probe point's right here. We probed 0.181, 0.479, and 0.533. So we got too thick a shim over here. This shim here might be all right. I think we need to thicken this one up a little bit and put a thinner shim over here. So I'm going to trade these shims out and we'll run this mesh again. And there we go. There is the most current height map. We still have a serious droop down here in the back left corner, but our probe points 0.578, 0.377, so that could come up just a little bit, 0.552. So those two right there are about as close as we're going to get it. I could put just a little bit thicker spacer here in the back. As far as getting this twist out of the bed, I just don't know that there's anything that's going to fix that, short of just physically grabbing the bed and bending it, which usually doesn't work out too well. I can continue to tune on this and get it really close. A 0.723 range is not great, but it's also not terrible. The biggest issue is these back corners. Obviously, the screw is right here. The point on the lead screw is right here. So adjusting this and adjusting this, not much you can do. Start messing around with the load cell points, which are right here in the four corners, is possible, but I'm not going to do that. Okay, post-video shooting, now editing studio, Scott, and it bothered me leaving the bed with that really bad shape. So I found a remix of the shims I used that actually are wedge-shaped shims. So I printed out some and I gave it a try. And as you can see, this corner that was way down here and this corner that was way up here, well, now this corner here is actually a little bit higher than this corner. So I need to reduce the height of the shim on this side. But the four corners, 0.479, 0.394, so I'm going to increase this one by 1/10 of a millimeter. And back here, 0.425, 0.340, so I'm going to drop this wedge on this side down 1/10 of a millimeter and reprint those and try them again. But I just wanted to show you, I did not think that wedge would work in that tiny little footprint back here, but obviously it does. So it's possible to get an even flatter bed, and there you go. I wasn't going to let it go the way it was, so I wasn't going to reshoot the whole video, just adding this in there. There you go. Back to the regular video, and we will finish this out. Okay, there we go. The obligatory benchy is printed, and I'll just grab it out this way. Doesn't look too bad, but I'll be real honest with you, a benchy's not going to tell you anything about whether or not the bed is level or how out of level it is, because it prints in a tiny little spot. And since I upgraded this, it runs the camp, which is the adaptive bed meshing, so it only bed meshes where it's actually going to print. I'll put a picture of that up right here. So that's what it looks like. That's all the more bed mesh there is. Just that one tiny little spot. It's not out that far. So anyway, that's it. That's about all I'm going to do to the K1s and the K1 Maxes that I have. They print all the time. They work great for me, and I'm just going to let them keep going. But hopefully these videos help. If you like them, don't forget to hit the thumbs up button. Hit the subscribe button. That helps out my channel. And if you want to see more videos, hit the little bell icon, and you'll be notified when I put up new videos. So don't know what the next video is going to be. I'll figure it out here in the next couple days, and I will get started filming it. We'll see you around. As always, I appreciate each and every one of you that take the time to watch these videos. And as always, peace out.